Hello, this is Mr. Bass. Welcome to Chapter 3, Homework Questions 93 to 98. Now, this is the first day of Lesson 332, so there'll be a second set of questions on the next video. Question 93, solve each equation. Be sure to find all possible solutions and check your answers. So, on the first one, we have the absolute value of x is equal to 7. So, on this one, we can tell pretty quickly, hopefully, that negative 7 would be a solution and 7 would be a solution. So remember, we're looking for two possible solutions on a lot of these, and we'll talk through that as we go through here. So x is equal to negative 7 and 7. And to check this, once again, you're just plugging in, showing that negative 7, that the absolute value of that is 7, and that the absolute value of 7 is also 7. So there's your check. Now, I might not go through and check every single one, but that's the idea on how to check these. All right, moving on to B. We have the absolute value of 2x is equal to 32. Once again, you might be able to do this one just kind of mentally saying, I need the absolute value to be 32 or negative 32, so what does x need to be? What we're actually doing here is we're saying that two values could possibly work. Not negative 16, sorry about that. That 2x could either be equal to a negative 32 or 2x could be equal to a positive 32, because both the absolute value of negative 32 and 32 is 32. So when we divide by 2, we get one solution of negative 16 and then one solution of a positive 16. And if you plug those back in, you get 2 times negative 16, which is negative 32, and 2 times 16, which is 32, each being that the absolute value is equal to 32. So x is equal to negative 16 and 16. All right, part C. The absolute value of x plus 7, that quantity, is equal to 10. So what can we plug in here to make all of this true? Well, we could plug in negative 10. The absolute value of negative 10 is 10, and also positive 10. So let's move that out of the way here. Whoa. I don't know what I did. All right, there we go. And now we can say that x plus 7 could equal a negative 10, or x plus 7 could equal a positive 10. Subtract 7, that gives us negative 17. Subtract 7, but since it's a positive 10, it gives us a different number of 3. So our solutions are x equals negative 17 and 3, and then I'll show you the check on this one. If we plug in negative 17 plus 7, is that equal to 10? And that'd be the absolute value of negative 10, so yes, that will work. But we also need to plug in 3. 3 plus 7 is 10, so the absolute value of 10 is also equal to 10. So once again, you do need to check both solutions when you're doing that. All right, and the last one, D. We have the absolute value of x is equal to 53.1, which is very similar to A. We're going to have x is equal to negative 53.1 and positive 53.1. And since it's just the absolute value of x, there's nothing else to do there, is that it can be either positive or negative 53.1. Question 94. Solve each equation below for the indicated variable. So in part A, we're solving for x. So we have 3x minus 2y equals 18. If you used algebra tiles, think about those as you go through. We're solving for the x variable. So a lot of times our first step would be to get rid of the other variable term, and we can do that by creating a 0. Negative 2y plus 2y is 0. So we're just left with 3x is equal to, remember the y tile is a different size than the unit tile, so these are not two things that we can combine. It's just 2y plus 18. And then now we want to break these up into 3 different groups, so we're going to divide everything through by 3. 3 divided by 3 is 1. So we have 1 times x, or x, is equal to 2/3 y plus 18 divided by 3 is 6. All right, on to part B. 3x minus 2y equals 18. Same problem, except now we're solving for y. So now since we're solving for y, let's subtract 3x this time. And what does that create? That creates a 0. And so we're left with negative 2y on the left side, and same idea as last one, we cannot combine the negative 3x and the 18. Those are different tiles. And then now we want to divide everything through by negative 2. So negative 2 divided by negative 2 is 1. So that's 1y, or y. Negative divided by a negative is a positive, so that's 3/2 x. And then 18 divided by negative 2 is minus 9. So here's your equation. Solve for y. All three of those equations are the same. They're just set up in different ways. All right, on C, we have r times t is equal to d. We're solving for the r variable. So to solve for r, what are we going to do to the t to help us out? Well, since it's r times t, we can divide by t. T divided by t is that giant 1. So I do to both sides though. So we're left with r times 1, or r, and then d divided by t cannot be simplified, so you just leave it as d divided by t. And on D, C is equal to 2 pi r. We're solving for the r. So C is equal to 2 pi r. This is the circumference of a circle formula, in case you were wondering. We're solving for r, so 2 pi times r, that's all multiplication. So we can create another giant 1 here by dividing by 2 pi. So 2 pi divided by 2 pi is 1. 1 times r is r. And that's c, or the circumference, divided by 2 pi. And that's what r would represent. Question 95. Evaluate the following rational expressions. So on some of these, once again, I don't want to over-focus on these, but to be able to solve these, you can use your calculator. That's perfectly fine, or you can solve them this way as well. No problem either way. We do have a positive 8 and a negative 3, so if we add those, that will be a 5. We have a positive 7/9 and a negative 2/9, so that would be 5/9. So we have 5 and 5/9. So I added my whole number, and then I added my parts of the whole number. But do remember, this is a negative 2/9 because that whole number represents a negative. On the next one, 7 and 4, that would be negative 11. The 2/7 and the 1/5, we're going to have to find a common denominator. So 2/7, and that is a negative, minus 1/5. We can multiply top and bottom by 7 for the second one, and 5 for the first one. So that's negative 10/35 minus 7/35. So that would give us negative 17/35. And so therefore we have 11 was also negative, so negative 11 and 17/35. On letter C, we probably want to rewrite these as improper fractions. So 1 times 7 is 7 plus the 5 gives us 12/7. You could also rewrite the 1 as 7/7 and then add up those two fractions. Times, and then 3 and 6/7 would be 27/7. And then we can just multiply straight across and simplify, unless we can cancel anything. And it doesn't look like we can cancel anything, so let's just multiply straight across. And we get 324 is equal to 49. If you do want to write it as a mixed number, we could. 49 goes into 324 6 times with 30 left over, so 6 and 30 over 49. Either way is fine. D, we have negative 8 and 1/7, so we want to take this mixed number and make it improper. That would be 57/7 times, once again, change that to an improper. That looks like that is 50/9. It is a negative, and we are dividing these two, so we want to go ahead and multiply by the reciprocal. And that will give us, let's go ahead and multiply straight across on this one as well. And we get 513/350. If you did write it as a mixed number, it's 1, and 163/350. Question 96. Find the equation of each line described below. So in part A, we're looking for a line with a slope of 0 that passes through the point 6 comma negative 11. If the slope is 0, that means we have no steepness, which would be a horizontal line. So you can say y is equal to 0x plus, where is it going to cross? Well, since it crosses the point 6 comma negative 1, then it will be at y equals negative 11. If you're not sure about that, think about going ahead and using your equation to help you identify that. Y is negative 11, your slope is 0, your x is 6 plus b. So you see that no matter what that x value is, it's always going to cancel and just leave with b equals a negative 11. Now, that is a very specific case when the slope is 0. So don't try to necessarily apply that in other scenarios. So y is equal to negative 11 is the equation of that line. B, a line that passes through the points 12, 12 and 20, comma 6. So the first thing we need to do is find the slope. So 12 minus 6, this is our change of y, over our change of x, which is 12 minus 20. So it looks like I get 6 over negative 8, which I can reduce by 2. And that would be negative 3/4, or if you wanted to, you could potentially write it as a decimal on this one. Now we need to figure out what the y-intercept is. So I'm going to use the point 20 comma 6 and then the slope of negative 3/4. So y, which is 6, is equal to m negative 3/4 times x plus b. Negative 3/4 times 20 would be negative 15 plus b. How do I know that? 20 is over 1, so I just canceled my 4 and 20 with a factor of 4. Leaves me with 5 left over. Add 15, and we get b is equal to 21. So we have enough information to write the equation. Y equals negative 3/4 x plus the y-intercept of 0, 21. And there's our equation. Question 97, graph the lines that are given on the same set of axes, then find the point of intersection. So we're looking for the lines to intersect. So we'll start with the first one. Y is equal to negative 4x plus 3. So what information do we have? We have the slope of negative 4 and the y-intercept at 0, 3. So we'll plot the y-intercept, go down 4 and to the right 1. Make sure your line is decreasing. If you want to go up 4, that's fine, but then you have to go to the left 1. So if you get enough points on there, use a straight edge. Label your line y equals negative 4x plus 3. And then on the second one, we have y equals x minus 7, slope of 1, y-intercept of 0, negative 7. So we'll plot that. Y-intercept first, and then up 1 over 1, up 1 over 1, and you can see, let me try that again, that the lines do intersect, and it looks like they intersect at the point x is 2, and then 1, 2, 3, 4, negative 5. So therefore the point of intersection, because we do want to make sure that we are answering this question, is 2, negative 5. So we've graphed the lines, we've identified the point of intersection as well. Question 98, simplify each expression using the laws of exponents. So on the first one, I'm just going to go ahead and expand these out. X times x, x times x, times y, times y, times y. How many total x's? We have 4, so x to the 4th because it's being multiplied by itself 4 times, and y is being multiplied by itself 3 times. So x to the 4th times y to the 3rd. On part B, we have x times x times x times y. So we're just expanding this out so we can see everything. On the bottom, we have x times x, and then 3 y's. So we're going to create all these giant ones. So there's one here, because x divided by x is 1. And then we have a couple with the y's as well. And then when it's all said and done, it looks like we are left with an x times y in the numerator, and the denominator is just left with a 1. On part C, I'm going to do the same thing. Now, this exponent of 2 is only for the x. So only does the x get multiplied by itself twice. Same thing on the next one, only the x gets multiplied by itself 4 times. So now when I have it all expanded, you see that 2 times negative 3 is negative 6. And then how many x's being multiplied by themselves? 1, 2, 3, 4, 5, 6. So that would be x to the 6th power. Negative 6 times x to the 6th power. And on D, so everything inside there is being multiplied by itself 3 times. And then you have 2 times 2 times 2. It's 8. And then x times x times x is x to the 3rd power.